Let's talk about symmetry. You have three types of symmetry. You can have symmetric with respect to the y-axis, which of course is your vertical. You can have symmetric with respect to the x-axis, which again is your horizontal. You can have respect to the origin. Remember, the origin is the point where your x and y coordinates meet. And again, remember, the origin coordinates are 0, 0. So you can have origin symmetry as well. By definition, for something to be symmetric with respect to the y-axis, for every point xy, positive x, positive y, on the graph, the point negative x, positive y is also on that graph. Now, when I talk about things like positive x and positive y and negative x and positive y, we have to go back and think. Okay, well, where are, for example, positive, positive? Well, for example, here is positive x, positive y in this quadrant, quadrant 1. Negative x, positive y would be in this quadrant. This quadrant here would be negative x and negative y, and this quadrant here would be positive x, negative y. So let's go back and read the y-axis symmetry again. It says for every point xy, xy, there is also a point negative x, positive y, negative x, positive y. So basically that says if something is y-axis symmetry, then something on this side of the y-axis and somewhere on this side of the y-axis, same location, different opposite signs, will be y-axis symmetry. Let's look at x-axis symmetry. It says for every point xy, the point x negative y is also on the graph. So for every point xy, the point x negative y is also on the graph. Notice that the points are opposite each other across from that x-axis, and that's how we know it's x-axis symmetry. How do I know if something is origin symmetry? Well, if I have for every xy on the graph, then the point negative x negative y is also on the graph. So again, here if I have the point xy is on my graph, then the point negative x negative y is also on that graph. Notice that I'm opposite, lining up opposite across from the origin, and that's how we know if something is origin symmetric. Let's look at a couple of examples. For the given graph, determine the symmetry. We're talking about, is it y-axis, is it x-axis, or is it origin? Well, let's think about this. I have a point on this side that's lining up with a point on this side. I'm opposite the y-axis, right? I'm opposite the y-axis, and this is positive x, positive y. This is negative x, positive y. By definition, that means that I am, right, go back, look at your definition. By definition, I am, where is it? There it is. By definition, I am y-axis symmetry. Let's look at another one. Here I have a point here, which is opposite over here. This is the point xy. This is the point negative x, negative y. I'm opposite what's looking to be the origin. Let's check that definition. Positive x, positive y, negative x, negative y. That's what I have. Therefore, this is origin symmetry. Okay? Let's talk about evens and odds. Even and odd functions, that is. It says if the graph of a function f is symmetric with the y-axis, that means for every x in the domain, then this will hold true. Then your function f of x is equal to the function if I replaced x with a negative x. Therefore, that function would be even. Odd says if the graph of a function is symmetric with respect to the origin, that says for every x in the domain, if I replace my f of x function with negative x's, that should be the same value as if I just negated the entire, every element in the function. This would be odd. Okay. Procedure for determining if even and odd. 1. Find f of x, it'll be given to you, and simplify. Then, replace your x's with negative x's and evaluate. See if this holds true. If it does, even. If not, continue. Find negative f of x means negate every element in your f of x function. Simplify. Compare it to if I had just replaced every x with a negative x and evaluated. Does this hold true? If so, odd. If not, then neither. Neither even nor odd. So let's see if we can figure out this first one. Okay, so it says, first of all, find f of x and simplify. I have f of x. It is simplified for me. There are no like terms. Now, second step, I need to find f of negative x. This is simply an evaluate. Replace every x in your f of x with a negative x. Okay? Now evaluate. One thing to remember is that a negative number raised to an odd power is negative, and a negative number raised to an even power is positive. This will help you with evaluating these functions. So here I have a negative x raised to an odd power. Negative number to an odd power. Let's go check. Negative number raised to an odd power is negative. So that says that this is going to be a negative 5x to the 7th. Here I have another negative to an odd power. Therefore this is negative. This piece is negative times this negative gets me a positive. Be careful with that one. This is negative times negative. That is a positive. Now, I am to see, right? I've found and simplified, okay? Now, I am to see if f of x is equal to f of negative x. Well, this is f of negative x. And does this function match my original? Well, no. It's off by a sign. So that means that f of x is not equal to f of negative x. Therefore, this means it is not even. Alright, well now I need to go and see if it's odd. In order to see if it's odd, I need to find negative f of x. That simply means to just negate every object in your f of x function. Alright, let me grab my white out here. I didn't mean to write an f here. Here we go. I want to negate my original f of x function, so I have 5x to the 7 minus 6x cubed minus 2x. I want to negate everything in there, right? Negative f of x. So negate each object. That's a negative 5x to the 7th. Negative, negative, that makes positive. Negative, negative, that makes positive. I'm supposed to see, right, I'm supposed to compare, I'm supposed to see if f of negative x is equal to negative f of x. Now, f of negative x is this function right here, right, this one, is this one right here. Is this the same as if I negated each object? Do these two match? Well, let's see. Negative, negative, positive, positive, positive. Oh, yes, they match. So that means that, yes, this is odd. Now, if I had said, okay, no, it's not even, and no, it's not odd, I would have then said it was neither. Now, this is how to do it algebraically. There, of course, is always a quick step to to mathematics, and that's understanding the rules behind it. So if we understand these rules, we can talk about the quick way of figuring out if a function is even or odd. Let's talk about the powers. If a function has all odd powers, then the function is odd. If the function has all even powers, then the function is even. And you can probably guess the next one. If the function has both even and odd powers, then it's neither. Okay. Oops. So let's look at this. For the example that we had, we got the answer to be yes, odd, correct? Now let's go back and look at the original problem and look at the powers. I have a power on the first x, the power here is a 7. I have a power here that's a 3. I have a power here, it's not written, but it is a 1. Remember when you don't write a power, it's a 1. I have a 7, that's odd. I have a 3, that's odd. I have a 1, that's odd. Therefore, this function is odd. And that's a quick way of finding out if it's even or odd. Let's look at another example using this method. Here's another example. Let's again look at our powers. I have the first power here is a 6. The second power here is a 2. The next one doesn't have a variable, so there's no power here, so we don't talk about that. 6 is even. 2 is even. Therefore, this function is even. Let's do it the long way. Let's do it the algebraic way, I should say. Okay? Let's find, remember our first rule is to find f of negative x. So that means to evaluate. So I have 5 negative x to the 6 minus 3 negative x squared minus 2. Let's go back and remember our rules. A negative raised to an odd power is negative. A negative raised to an even power is positive. A negative raised to an even power is positive. A negative raised to an even power is positive. This is positive. Positive times a negative will be negative. And don't forget we have that minus 2 on the outside with no variable. Now in order for this to be even, we're supposed to look at if f of x, apologize, my pen is acting up here. We're supposed to look at if f of x is equal to f of negative x. Here's my original f of x function. Is this function, sign-wise, right, and everything, match my f of negative x? Well, I've got the positive, positive, negative, 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 yes, it matches, right? This checks out, so yes, even. You can find this algebraically. You can also find it with the quick trick talking about the powers. Here's just a quick example. Let's look at this. F of x is 8x to the 6th minus 3x cubed plus 4. Let's do it the quick way and understand what this one will be. I have a power here of 6. I have a power here of 3. And remember, there's no variable here with no power, so we don't worry about that. 6 is even. 3 is odd. Therefore, this function is neither. And that's talking about evens and odds and symmetry.